हेलो बच्चों, कैसे हो आप लोग? See, in the last videos we understood electricity. That means when you pass electricity to any electrical appliances, like in your fan, they will going to rotate. Or mixers, grinder, in your homes are rotating, right? When you pass electricity, they will rotating. That means when you pass electricity, electrical energy is converted into mechanical energy. I think you have experienced that, might have seen inside the fans, inside the electrical appliances, you saw the motor kind of thing. When motor is there, when that will going to rotate, right? That will rotate, it will give the mechanical energy, like fan or mixers, everything will work because of rotation of the motor. So what actually the principle of that motor, how it will going to work? When you pass electricity, how it will going to rotate? Okay, the questions are answers to all these questions we're going to see in the chapter, that is magnetic effect of electric current. Okay, when you pass electricity, electric current converted into this magnetic effect. Okay, that is what we call magnetic effect of electricity. I think in your class 8th and 7th you have learned, when you pass electricity converted to heat energy like bulbs and all. And when you pass electricity, it is also converted to light energy like your bulbs. Okay, heat energy like iron heaters and all works, right? Similarly, when you pass electricity, the fans and all rotate. No, that is principle is nothing but magnetic effect of electric current. So when you pass electricity, so magnetic field is producing or not producing. So how it is? So everything we are going to learn in this coming slides. Clear, children? See, first you'll see what is magnets first, because we are understanding magnetic effect of electric current. So we need to have idea regarding the magnets, right, children? Yeah, let us take which color? Blue. Okay. I hope you like blue color, right? So a substance which attract a small piece of iron, right, children? There is no any definitions, like you no need of explaining all this, because in the 6th standard itself you know all this definition, right? What is magnet? Okay, nobody don't know that. Everyone knows, right, what is magnet. It will attract other magnetic substances, like you take a iron, nickel, cobalt. So all these are magnetic substances. Okay, they will going to attract another substances when it is comes nearby it, like children. The substance which attract a small piece of iron points toward the north-south direction when suspended freely. So they give a magnet and their properties also given. Naturally occurring iron ore, which is called as a lodestone or magnetite. Okay, which is a natural occurring magnet, also behaves as a magnet but is very weak magnet. The one which we see made from them artificially, they have the permanent or the strong magnets. Okay, some properties of a magnet they define. Magnet has a two poles, north and the south pole. Like poles will repel each other and unlike poles will attract each other. They always exist in the pairs. Okay, repulsion is only the show test of magnetism. So what is this? All the slide indicates that you know what is a magnet. First of all, it is a one of the iron ore. Okay, one of the another form of iron ore, that is what we call as a lodestone. It's naturally occurring in the lodestone or magnetite. I think in the 6th CBSE some board you have studied fun with magnet theory. You study, no, how this magnet was invented. In case of Greece, they invented this magnet. The Greece man invented this magnet. Okay, that is a lodestone, naturally occurring magnet. They have less power actually. Okay, it is naturally occurring but have a less power. To make this magnet go more power and a permanent, that time they will pass electricity and they will create like a magnet. So that is okay. When you pass electricity to the magnetic substances, you can able to magnetic substances, you can able to create the magnet. Okay, so how it is possible, right, children? How it is possible? So what is the difference? Suppose you will take one iron rod and you will take one magnet. Okay, this is a magnet and this is iron rod. So why only this will have the property to attract? If you take the two iron rods, they won't attract, right? Okay, if you take only magnet, will going to have that property. So how it will gain that property? Because magnet, you can see the internal structure of magnets. Very important, children. Try to understand internal structure of a magnet contain. See, you know, in case of solids or whatever molecules, any matter you take, inside a matter, what happens? The particles and molecules are arranged. In a case of other things, molecules are randomly arranged. Only in case of iron, sorry, only in case of magnet, okay, that will be arranged in this manner. Right, children? Suppose you will take one iron, you can see the particles will be arranged wherever they want. Just randomly arrange the molecules, sir. The knot will be oriented in single direction. But in case of magnet, all the particles will be aligned in the single direction. So that what happens? Suppose enemies will come to your home. If only one will fight in this direction, only one is fighting, what happens? So the enemies will kill you. Okay, instead of that, all will fight together. What will happen? You have more strength. So that is why here all will be in unity. That is why they have more strength actually compared to other material. Other materials, because they will be oriented, one will go in other direction, one in other direction. There will not be unity like this. But here all have the unity. They go in a single direction, so that that magnet will have the special property called attractive and repulsive property also. I hope this is clear, children. Then, so this alignment, you can able to bring the alignment of the particles in any material, okay, this manner by using any energy, then you can make that material as a magnet. So that is only we are doing here, to make the magnet when we are passing electricity. So try to understand one experiment made. See, electrons. What is electric current, children? How many electrons are the charges flowing inside a current per second? That is what the electric current. When electrons are moving with a high speed, imagine how they are moving. They are moving with a very, very high speed. Electrons are moving with high speed. So what will happen? When they are moving the high speed inside, so outer particles which are present, they'll also try to go towards in the same direction, because you have experience when you are going in a train. Okay, suppose when any train with railway track, you imagine. Suppose a train is going, your parents don't tell you that don't stand near the railway track. So what will happen? If a train with a goes the high speed, you may have lean forward. Okay, you may get lean forward because whatever air particles surrounding. Suppose something is going in this direction, other particles which are present, they create low pressure, right? The earth creates low pressure. To fill that high pressure to low pressure, the winds are coming to blow like this direction. That is why you might have fall inside. So same reason here also, when electron is flowing with a high speed, okay, electron is moving with a high speed inside your conducting wire, outside it creates a particle alignment. See here, particle alignment is nothing but what? Magnetic field. Right, so that in the air we can able to create a magnetic field around the current carrying conductor. I hope what I am telling is clear to you, right, children? Current carrying conductor, the current is carrying inside a conductor, means what? Electrons are moving with a high speed, so that outer particles which are present, they try to align or circulate around that wire. That circulation are in the same direction. No, that is what we call magnetic field. So that means if current carrying conductor produces a magnetic field around this. So this experiment done by Ascodes, if you want, you also going to check, take one compass box. Okay, compass box, you know, right, children? That is a round circular thing indicated by north, south, east, west direction they're going to indicate, and they taken a magnetic needle. Okay, inside the magnet. This compass specialty is that which direction magnetic field is it, that direction this needle going to oscillate. So when you place your magnetic needle, so that it will show the deflection, means that magnetic field is going around the conductor. That is why in your home, suppose you are using any electrical appliances, your parents insist you don't bring any magnets near the TV or near the refrigerator, because why? They are creating electromagnet inside the refrigerators, and that is why if you bring outer magnet, sometimes you'll get to attract, and this will leads to some shocks also. Okay, children? So that is what about the magnet. So now trying to understand what are the properties. So mechanism of magnet is clear, no? Why magnet have the property to attract a repel? Because all the molecules inside the, okay, all the molecules inside the magnet, they will be aligning a same direction, so that it have getting the so much of strength to attract another material. I hope this is clear. Then what are the properties of a magnet? See, magnet will having a properties that suppose it will always dipole. Dipole means two poles, north pole and south pole. Any pole means end points. Remember, what is the poles? Don't confuse. They're nothing but end points. Magnet always will possess the two end points. It never exists in a single. Right, children? See, this is a magnet. It will always having end points. Suppose you take any material. Okay, definitely they have two end points. Right? Like that also. Magnet also having the two end point. One is north pole and the south pole. Okay, north pole and the south pole of a magnet. See, and magnetic field, suppose You will take any magnet is there. If one more magnet you are going to bring in this field of vicinity, magnet or any iron piece you are going to bring, it will try to attract towards it, or it will suppose magnet means try to repel it means a light pole. So that time what happen, up to some extent, some distance from here to here, it will going to attract. If you get more up after more distance from the magnet, it won't attract. That means up to which extent it will going to attract or repel a more magnet or magnetic substance, that is nothing but the field of a magnet. Magnetic exists, magnetic field. Like earth, right children, earth will exist a gravitational force, right, up to above 150 kilometers above the earth. Suppose it's earth about 150 kilometer, gravity will going to pull you down. So that is attraction force of earth, because it is also gravitational field what we call. Here also same thing, magnet is also exists up to some maximum to going to attract another magnet, like in a sphere. So three-dimensional sphere if I imagine. So this is what I call a magnetic field actually. Clear children? So magnet will have two poles. One is north and south pole. We cannot separate north and south poles. Okay, if you now cut into two pieces, again that small having north and south, again other piece also having south and north. Okay, north and south, and this will having this side south, this side north will come. Again you're going to divide this into again two pieces. Again this is north south. Again the small piece having north and south. How many number of pieces you keep on going to cut up to infinite? Yes, children, small error. Okay, now you can understand what is a magnet and what are its properties. First property is it will possess always two poles, north and south pole. We cannot able to separate like north pole separate one, south pole separate one, we cannot do. But in case of electricity, we don't know two charges, positive charge, negative charge. We can able to separate the positive and negative charges because it is a charge, number of electrons is a number, so that we can count it 1 and 2. But it is not it is a monopole. What we can, mono means single, but it is always existing dipole, so we cannot separate the magnet into two poles separately. Okay, and the like poles always attract each other. Sorry, like poles always repel each other, and unlike poles will attract each other. So how it is? So imagine the magnet will always exist north and south pole, right? Here north pole continuously emitting, okay, field of lines. That is what we call field of lines around the magnet. Like this, the field of lines will be, okay, it will generate at north and it will be end at south pole. So like this, magnetic field of lines coming from north and it will merge at south. So this magnetic lines of force, what we call as a magnetic field lines. Okay, because of magnetic field around this vicinity, it is going to exist magnetic field of line. So imagine it is coming from the north. Suppose imagine one water pipe is there. Okay, now one more water pipe you brought here. Okay, I'll just write here. Okay, one water pipe, and here also water pipe. Water is continuously coming from both with a high speed. With the coming here also water is coming with a V speed. Here also water is coming with a V speed. What happened, children, now? Because this high speed, both because of that force, what will happen? They're going to bounce back. This is also go away. This is also go away. Why? This two water, whatever this coming and rushing, they will going to repel because water force is more. Like that only here also. North pole is continuously, see here this north pole, imagine here also north pole. If you place two north poles, what happen? Water will coming with a high speed here and here. What happen? They're going to push away each other. Here it will go, this will go. That is why we can see repulsion phenomena, like poles means. Similarly, unlike poles, how they will attract. Suppose in one pipe water is coming, in other pipe there is no water, it is empty. So what happen? Whatever the coming water will try to accept this pipe, right? So that water will go into this pipe. Right, children? So they will going to attract each other, and they always exist in pairs as a pairs of poles. Okay, always exist in this one. A north and south pole, it will exist, never exist in single pole. Repulsion is only the sure test of magnet. Why repulsion only sure test? Even though it will attract, no, we cannot take attraction, because if you're going to drop any object, what happen? It will going to fall towards the earth, right? Earth does not have the repulsion property, but even though it will exist attraction, right? So that gravitational force, because of gravity, they will make attract. That is why repulsion only we take it as a show test. Suppose you will taken one iron, one is magnet. Okay, one is iron and one is magnet. You take this iron will going to attract it. Okay, but this is how it is a magnet. Now it is not magnet, even though it is attractive. So magnet means, oh, this is also magnet, this is also magnet. That time they will like pole, they're going to repel each other. No, that time we will get to know both are the magnets. That is why short test of whether it is a magnet or not, we need to find using repulsion only, not through attraction. Okay, even though it is iron also, it will attract. Or cobalt, nickel, any magnetic material also they will attract. Right, children, regarding magnet and its properties. I hope this is clear, children. Just a second. Next, we'll see magnetic field lines. Okay, what are magnetic field lines? Let us see the region around the magnet where the force of attraction or repulsion can be detected is called as a magnetic field. I don't know if you take this magnet, north and south pole, up to some extent it will going to exist the field. Okay, that is in the vicinity of this any magnet or any iron field, iron fillings is going to keep what up, it will try to attract towards it. Suppose the north, one more north pole is going to repel each other. That means up to some extent it is going to, suppose you will take earth above 150 kilometers trying to attract all the object what is there in this field. So that is what earth gravitational field will come. Like this only here also, magnetic field means up to what extent it will going to attract or repel another magnet when it is brought in the inside the field. If you place outside the field, it would only when it brought near to the field, that time it will attract. That field up to what extent it will attract, no, that is what we call the magnetic field. Okay, the reason where. And magnetic field around the magnet can be detected using the magnetic compass. See what we taken here, magnetic compass. You can also know this is a magnetic compass. This red color shows the north and white color here, nothing is quoted, no, that will show the south. This is south and this is north. So you keep on put the north and south, you can see the magnetic lines of force coming from the north. Okay, it is showing a deflection, that means the field is moving in this direction. Here also it is showing outward, that means field in this direction. Here it is showing. So first thing you understand compass, why we going to use compass needle, always align in the direction of magnetic field. Okay, it will always align in where, in direction of magnetic field. That means if magnetic field in this direction, show the north and south direction. North always shows the direction of magnetic field, opposite to south will come. So this is showing like this, magnetic field is like this. Again, where it is coming to showing towards the south. Again, this line is also going like this, coming towards the meeting here. Again, this line is showing to see this magnetic line's direction. So it is going inside the north like this. Okay, so like this magnetic lines of force we can able to test using by putting the compass box around the magnet like this. Clear, children? This is, I hope this is clear. You can do magnetic field lines experiment by taking a cardboard and you can put some of the magnetic fillings on the cardboard and you just put the magnet and just try to trap it. Okay, that time also you're going to experience that. Yeah, here in your book they given magnetic field of lines, one activity that you taken a cardboard first. Okay, you just taken a cardboard, in that you placed one north south bar magnet in your laboratory, what is there. Okay, bar magnet, and you just spray the powder from the top like this. You just spray the powder from the top. Okay, and after just simply give the tap to that cardboard. Okay, after you can see it off. Okay, after tapping you can observe that this is the pattern. Okay, this pattern, see, you can see at the poles more magnetic fillings are there. Here it is going, and at the middle it is going like this. The lines you're going to observe, the powder will be spread like this. That means it is like a figure, it is looking like this. The magnetic field of lines, they never intersect. They are moving from where to where? From north to south, and inside the magnet means they will move from south to north. That is why magnetic field lines are closed lines. Okay, magnetic field lines are closed path. They are not ending. You can see it is ending here to here only. No, it is not semicircle. It is a complete circle loop. It is outside. It is appear like going from south to north, and inside from outside north to south, and inside it is looking like south to north. Okay. Suppose now you place magnetic compass here, where it will show direction. North side will come this side and south side like this. Suppose you place magnetic field here, compass box here, where it will show direction north. Okay, north it will show like this, south will show like this. Okay, this is what a magnetic compass box show. That means field lines are going like this path, and this side also magnetic field lines going in this path. Suppose you place magnetic compass box here. what will show? It will go inside. So north will come here, south will come here. Suppose you place magnetic compass box here, it will show north this side and south this side. Okay, that shows it will go in the direction of magnetic field lines. Okay, yeah. Next second, children. Okay, properties of this magnetic field lines they're asking. Let us see what given. Magnetic field lines are paths around the magnet along with the north pole of a magnet compass needle tend to move. Okay, north magnet. If you keep on going, that is tend to rotating, circulating like this. The magnetic field lines around a magnet can be observed by sprinkling iron fillings around a magnet like this. This activity, okay, can be observed moving magnet compass like this. You can observe. Okay, magnetic field lines emerge at the north pole and merge at the south pole. Emerge means coming out. Okay, they're coming out. Merge means they're coming to contact or going inside. Okay, going in. Yeah, coming out. Okay, coming out we call from the north pole. Emerge from the north pole and going or merge into it is from south pole. Okay, magnetic field lines are closer at the poles. What will happen? Magnetic field, you can see now here the distance is very less, but here you can see more distance closer at the pole. That is why when they are magnetic field line, number of lines passing per unit, that is what the strength of the magnet. Okay, so here you can see per unit area, here also same unit area I take here. So number of lines will be 3, here number of lines only 2. That means number of lines are more at pole, so that pole will have more strength. Okay, poles will have more strength because number of lines are very closer at the poles, and magnetic field lines do not intersect each other. So if they need to intersect each other, suppose imagine this is the north and south pole, magnetic lines are coming here to here, again this will go like this. Suppose imagine they are intersecting. Suppose now you need to place your compass box. How it will show direction, children? It need to show, suppose imagine this is zoom and I am saying here. So it is the 2 lines are going. One line is go like this, one line is go like this. Suppose intersecting. Okay, 2 lines have come and intersect like this. Imagine in this place you need to place the compass. But whether it should show direction this side or this side. At a time, is it possible to show both the direction? Right. Suppose north pole always need to show this direction and this direction need to show the direction. Right. Magnetic needle may be deflecting any one direction at a time. At a time, 2 types of deflection. It will be this side also, it will be that side also. Is it possible? Right. Suppose you are there here standing. You are possible to stay at one place only at a time. You cannot go other place also stay at the same time, right? So that is what it is actually magnetic field of light. They never intersect each other because the compass path does not show the 2 deflection at a time. It cannot able to possible at all. So magnetic lines, that way they never intersect each other. I hope magnetic field lines is clear to everyone. This is nothing but magnetic field lines. Yeah. Okay. See, we can do this activity in a book also given to understand magnetic field lines of magnetic field lines by passing the electrical current in a straight carrying conductor. We taken one straight carrying conductor. You can observe this wire. No, this is the straight current carrying conductor actually. Here we made, yeah. You can observe this is a straight current carrying conductor. The current is passing, but by connecting some cell or battery, we are passing the current into that. When the current is passing, this is a positive negative because current is coming this direction. Okay. When current is passing through this conductor, I told already, when current is passing through the conductor, electrons are moving with a high speed. Because electrons are moving high speed, there creates a low pressure, right? So to feel that whatever the particles are there outside the wire, they will try to align and they try to circulate around the wire. This circulation, the alignment of the particles act like a magnet. Inside the magnet, how particles are aligned, right? So that is what we can observe here. Magnetic field lines will be generating around the side current carrying conductor. So how you can do experiment? Just to take one cardboard, put iron filling. So okay, sorry, if you take the cardboard and make a small hole, okay, let's take a cardboard, make a small hole in the cardboard and insert that current wire passing and connect to the some cell or battery and pass the current. Okay, when you're going to pass the current, what will happen? Here electricity is passing, that means electrons are going the high speed, so magnetic field is circulating around it. That is, we can prove by keeping the compass box. Okay, you can place here one compass box. Okay, in that the deflection can show. Okay, now you can place one compass box containing north and south. It will show the deflection. When current is moving downwards or current is moving upwards, based on that the north pole and south pole of a ball magnet we are going to deflect. Compass box going to deflect. When current is moving, see here, when a current is moving upwards, when current is moving upwards, that is a concentric circles you can see outwards. Okay, you still the iron fillings now also. You can put some iron fillings on that, just to trap it. What happen? They will always come and align in a concentric circles, all the magnetic fillings. This shows that magnetic field of lines around a straight carrying conductor are a concentric circles. Okay, they are not like a concentric circle. Meaning of that is, if containing only center, around the center with a different radius, you can able to draw the circles. So that is what we call concentric circles. Okay, center is same but radius is different. Okay, that points what that circles what is a concentric circle. So in a straight carrying conductor, we can able to observe that concentric circle. That is nothing but field lines around a straight current carrying conductor. I hope this is clear, children. Yes. See, to find the direction, which direction, suppose you taken a current, it's going from down to up. Okay, current is passing from down to upward direction. In that condition, how the magnetic field will be direction, whether it's clockwise direction or anti-clockwise direction. So you're going to find that using the right hand thumb rule. So let us take your right hand. Okay, children, take your right hand and the direction of thumb indicates the direction of current. Imagine in this pen, the direction of current, if a current is going upward direction, this thumb need to point in the direction of the current, and the curled finger, you can observe of the fingers which are curling around, that will give the direction. So like this, you can see the figure also there. Your thumb indicates the direction of current and the curled finger indicates the direction of magnetic field around. So this is what a right hand thumb rule. Clear, children? What is right hand thumb rule? Take a conductor. Suppose conductor is there, the current flowing in a conductor represented with the thumb. Direction of the current represented with the thumb, and the fingers curl around the conductor, that will show the magnetic field circulating around the conductor. Suppose current is going upwards, you can see the fingers how they are rotating, they are going in a clockwise direction. Now current is going downward direction. Okay, when current is going in a downward direction in the conductor, you can see the fingers going in anti-clockwise direction. Okay, clockwise and anti-clockwise direction, or east to west also we can call. That is based on right hand thumb rule. We're going to take very simple, take a thumb, which direction current, and the curl finger magnetic field. Rotate, or which side you want, you can just rotate and you can find out it easily. Clear, children? This is about right hand thumb rule actually. Okay, let us want just read words. The direction of magnetic field around a conductor is given by right hand thumb rule. Here shows that it states what it will state. Statement they will ask for board exam. Okay, you have to understand how it will state. If a current carrying conductor is held in a right hand such that the thumb points in the direction of current. See, the thumb points in the direction of current. Then the fingers wrapped around the conductor. This is the fingers wrapped around the conductor. That will shows the direction of magnetic field. Clear, children? This one. If you reverse the conductor downwards, the field lines is also changes. The clockwise and anti-clockwise, it will going to rotate. Yes. See, in case of straight wire, straight wire carrying current conductor, magnetic field lines are concentric circles around like this. Now, what we made this wire, instead of straight, we made into curve, okay, rotate like this. We just make into a loop. Now, just connect this loop to positive and negative terminal. That means the current will flow through this. When the current is connected positive, so that current will be going in this direction. Okay, current is going in this direction, current is going. So how to write the magnetic field of length? That is what just a trick. See that you take a right hand and suppose now in a circular ring. Okay, in the circular ring, it is current is going this direction. Imagine fingers will be in this direction. Suppose in this point you can take. Okay, at exactly at this point you take, current is going like this. Okay, upward direction. So curl fingers are coming from there to inward. That is why you can draw now here from outward to inward. Your thumb, this thumb is pointing this side, so field lines will be circular around, so that it will be circular. At this point you can take again your circles. At this point you can take the circles like the keep on. You can see now all the way circles, and how the circles never not 1 or 2 point. No, circles here keep on increasing like this. Okay, 2, 3, 4, 5, like that keep on increasing. So as it is coming outwards and outward, what happened? Radius of the concentric circles keep on increasing. At a point will come, the radius is very large. That time what happened? It is just an arc of very big circle. Okay, that is why at the center of the loop, current carrying loop, you will get the straight line. Okay, you will get the straight line actually. Okay, suppose the 3D wave you just observe, it will like a just say this is also, this is also. That means all the lines are meeting at the center, no, with a large number of field lines are there. So very large number of field lines are there. That means what? Strength is very high at the center. At the center, strength is very high compared to the at the other sides. Okay, children, this is what we call magnetic field due to a circular loop. When a current, yeah, you can observe here the straight line at the middle, it is straight line, and outerwards it is a concentric circles. You can observe here when a current is passing through a circular conductor at the loop, the magnetic field produced is in the form of concentric circles around the conductor. Towards the center, the arc of a circle becoming large and appears like a circle. That means this is a when radius is appearing very very large. You can see, no, it appears like this, like this, and it is just like a very big circle. Okay, it is from like coming like a big circle. It is coming like. Okay, children, this is regarding the magnetic field lines of a circular coil or circular loop. Okay, I hope this is clear to you. We'll solve problems based on this. I think that time will be clear. Okay, now let us see magnetic field due to a solenoid. Okay, in case what is this solenoid means and how magnetic field will be inside the solenoid. Okay, let us see that solenoid, that means just we taken a spring. Okay, you can observe in case of the spring, in case some pens and all the spring will given like that, it is the just a spring. Instead of one circular coil, we taken a spring only. Okay, and the spring, the two ends of the spring are going to connect with the some current supply, like some battery, some switch we're going to connect. So this is only act like a solenoid. Clear, children, what is a solenoid? Solenoid means the circular loop, number of loops are more. Okay, like a circle, we were taken only one loop when current is passing through this loop. Here taken number of loops in the form of a spring it is. Okay, you can observe on this figures, no, the spring, like we taken one metal core. Okay, around that you're going to connect the spring, and the spring will going to connect to some electric supply. So this will act like a magnet now. So how it will be? Solenoid is a circular coil or a wire in the shape of a cylinder. Okay, circular coil in the shape of it is like a some cylindrical shape. You can observe outside it will like a cylinder. When a current flows through the solenoid, it behaves like a bar magnet. So when current flow, it behaves like a bar magnet. Why it is? Because see, each circular loop, what you can take, children, in case of circular loop, if current is flowing in the up in this direction, if current is going in this direction, you can observe no magnetic field lines almost straight. It will be coming outwards, right? Suppose imagine that is the current is flowing in this direction, where the current is going in the upward direction, magnetic fields are like going outward direction, right? So like that only. So if you take number of loop, like all the magnetic field appears to coming from north, okay, one end, and they will be merging at another end. So this is what a figure of a current carrying solenoid. When current is passed through the solenoid, it will be like concentric rings, and they all coming to merge from north to south. Okay, coming from this end and coming to south end. It is like a bar magnet. How the bar magnet, children? In case of bar magnet also, north pole, south pole, from north pole lines of field will originate, and south pole they will to intersect. Okay, like this only in the north pole and south pole in the bar or magnet. So like that only here also, it will be like if you pass electricity to a solenoid, it will be all the magnetic lines of force, they will try to coming from one end and they're going to merge it another end. That means which are coming, we can call it as a north pole, and which is coming out that act like a south pole. Okay, still simple, you want to remember which side is, suppose they given nothing north and south. In this condition, which condition will be north and south in this figure means which is connected to the negative end, that end will be act like a north. Remember, negative means north, and which is connected to the south, that will be act like a S, south pole. So you can remember like this the poles of a solenoid, or even you want to just clearly, that is what we call a clock rule. Okay, clock rule. When a current is going, okay, which phase we are going to see? Okay, that is what we can call it as a clock rule. Current is going in anti-clockwise direction, or current is going in clockwise direction. If it is anti-clockwise, we can take it as an anti. Remember, anti means what? N will come. So north pole. You can write here north pole. Sorry, north pole. Okay, anti-clockwise. It is going in south. So clockwise, it will go in a south pole. Dear children, so south and north pole, based on current is going in anti-clockwise or current is going in clockwise. Suppose some current loop is there. Okay, this is a current loop. If the person is seeing from this end and person is seeing from this end, for both of them, the direction of current will be different. So according to first person view, it is going like a clockwise. But according to second person view, for him it is like a what will pole? This is south pole for him. That is why it will contain north and south pole also. That is what, suppose it is a circular disc. In the circular disc having the north and south pole, which direction you are going to view, that is also matters here. Clear children? Based on that you can remember clock rule, or you can remember this negative means north pole, south pole positive connected, that is act like a south pole in the solenoid. When solving the problems, these tricks are we going to work out for you. I hope this is clear, children. Okay. The strength of a magnetic field depends upon the strength of a current what you are passing and number of turns in the coil. Here only few number of the turns, 1, 2, 3, 4, 5. So n is equals to how much here? 1, 2, 3, 4, 5, 6. Okay, only 6 number of the turns are there. So magnetic field what we call as a B, that is be directly proportional to number of turns. Here only 6 strength is less. You can observe here more than 6. Strength will be more. Here only 3, strength will be less. So based on number of turns, this number of turns are there, that will be directly proportional, and also depends upon how much current you are passing. If you pass more current, more field strength. If you pass less current, this number of lines you can observe. So based on the current, it will also depend strength of magnetic field, and it is also depends upon the factor called mu. Okay, it is a constant permittivity. Okay, magnetic permittivity or permeability we can call. So this is also matters. So all that we can write B is equals to mu naught N I. Clear children? This is the formula of magnetic field around a solenoid when you solve. Okay, see, and one more, when the problems will ask, magnetic field inside the solenoid it is uniform all the way. If you come to the end, it will going to decrease. Magnetic field, it is decreased to 1 by 2 times. Okay, B by 2, that is mu naught Ni by 2 at the poles. At the inside, it is this formula. At the poles, it is decreases to half. So how it will come? We just derive later. Just try to understand inside a magnet. Suppose I will given 3 points here. Point A, point B, and point C. Okay, in this point where the magnetic strength is more, at the point A strength is more, point B half of the A strength. You have to see no, because it is out of the field. So magnetic field never not exist here. Clear children? Like this problems will be coming from NTSC also. Please try to concentrate this. Okay, thanks for watching children. This is a part 1. Part 2 we are going to discuss still more continuation of this chapter. Thanks for watching. Thanks for supporting. Please, my request is that while you are watching this much interesting videos, please share to your friends who are there. It will be advantage for you also. Okay, thanks for watching. Bye children.